Right, we're going to apply the same methods that we've seen in the last two shapes to a different shape. This is St. James Parish. It's a little different to the other ones. You can see it's got less of those sort of these white spaces. It's more connected. It looks more meshed. So the other one we looked at previously was Westmoreland. This is St. Elizabeth. Now we're going to have a look at St. James, which is a different shape. Because it's different, we expect it to take a different amount of time to process, but also have different types of shapes. So let's see how the algorithm performs on this particular parish. Right. The first job is to load the data. Okay. Right, so that's the data in, and what we have to do first is to generate the bounds. How are they linked? Okay, there we go. We have the bounds. Next step is to actually let's go through and extract the shape using this extract call. Okay. Let me leave it to process. Because this shape has it's got a higher degree of connection compared to the other shapes. There's less of those self-closing loops. You expect it to have a different running time, and also you can see just from the numbers you've got a higher numbers in the you've got a higher amount of linkages than you've seen in the previous shapes. Here we're seeing 372 as the maximum bound length. In the previous ones we were seeing 150s, 160s. Okay, so it's just finished doing that. So we've got to scrub the output for shape X. So we've got to do shape X. Okay, we've got to scrub it. Okay, that's done. And now we've got to plot it. So shape extract. Right, okay, so that's all the lines. So same as previously, we've got to hide all the suspected shapes and then individually go through and inspect. Okay, yes, we agree, null 0, that's the outer line. We understand that. Yes, that's a shape. There are no lines sort of crossing the white space, so it's indeed a shape. Yep, so is that. Yep, that's a shape, so is that. Nope, this is an XO shape, so we can skip that. XO shape, that's a shape, so is that. Shape, another shape, shape. That's an XO shape. Yep, that's an XO shape. XO, XO. That is a shape. XO. XO. That's a good clean shape. That's an XO. XO. More XO shapes. Again, more XO shape. But this one is an XO shape we might be interested in because you can see the only area that's got that the remaining space after all the other smaller shapes have been found. So it might be interesting later for us to have a look at this this particular XO shape. But for now, we'll just ignore it. Ignore that. Ignore that. Ignore that. Yes. Another XO shape. XO. 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 This is interesting. Yep, this is a shape. There are no other lines crossing the white space in the interior, so we like that. That we don't like because it's being crossed by this lighter brown line, so we ignore that. XO. 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 Another XO shape. Ooh. Ooh, that's a good one. Yep, nice and clean, no lines crossing its interior. that one is an Excel shape. Right, so there we go. We've managed to find all the shapes that we can possibly have in this, except of course this white space. Okay, so that's pretty good. That's a quick overview of this particular method.